itself perfectly between the sun and the Earth. The moon is 400 times closer to the Earth than the sun, and by extraordinary cosmological coincidence, it's also exactly 400 times smaller. Diego and his astronomical colleagues will travel anywhere on Earth to study this rare celestial event. Each eclipse will last just a few precious minutes.
The temperature starts dropping, and it drops up to about 10 or 15 degrees in some cases. It's very noticeable. You feel this wind, this atmosphere just agitating, and it is very, very tense moment. Then you look at the west, because the shadow of the moon is coming towards you. Very fast, at 3,000 kilometers per hour. The landscape loses its colors.
A 100-mile-wide shadow will pass over the surface of the Earth. The brightness of the midday sun will slowly turn to night.
The sky gets so dark that the corona, which is very faint, is now visible. It really flourishes. It's like a flower, a white flower that opens its petals in the sky.
This is the sun's corona, a glowing atmosphere normally obscured by the intense glare. It burns at over 1,000,000 degrees. Giant prominences erupt from its surface. They could swallow the Earth dozens of times over. Like giant fingers, they stretch for millions of miles into the vacuum of space. But for solar astronomers like Diego, a total eclipse is over all too soon. After just a few minutes, the alignment is lost. The sun's brilliant light bursts out from behind the moon, a magical sight that eclipse watchers have named the Diamond Ring.
When you finish looking at the diamond ring and you see the shadow of the moon rushing away from you now towards the east, then you see that was it. Those 2 or 3 minutes are gone. You have been waiting for that for years, and suddenly it is gone. You feel like a vacuum, and you say, this is not enough. I want more.
As the sun breaks out from behind the moon, once again the Earth is bathed in its light. We rely on the sun's constant energy to breathe life into our planet. It gives us free energy. Its heat evaporates water to produce the clouds and rain. The slightest change in its behavior could put the world and even the human race at risk. To keep a constant vigil on the sun's enormous power from above the Earth's shimmering atmosphere, a new satellite, SOHO, was designed and built by NASA and the European Space Agency. Launched in 1995, SOHO was to promise a breakthrough in sun observations and give astronomers a front-row view of our nearest star. Douglas Gough, a solar astronomer at Cambridge University, was one of the members of the SOHO team.
The satellite has gone to a position between the Earth and the Sun, where the gravitational pull of the two cancels. So it sits there looking at the Sun continuously and beaming back the information to Earth.
The images it beamed back were beyond their wildest dreams. The Sun's raging surface is a turbulent world, its eruptions ripped and torn by enormous magnetic fields. SOHO revealed that, like the Earth, the Sun has weather. Gigantic solar tornadoes twist through its atmosphere. And gigantic shockwaves rip across its surface. The surface of the Sun is heaving. Every 5 minutes, the entire star breathes in and out. Our Sun is pulsating. This is the real sound of it vibrating, speeded up thousands of times.
The outside of the Sun is in a very dynamical, turbulent motion, just like the turbulence behind the back of a jet engine. The jet engine creates a lot of noise. Similarly, this motion creates a lot of noise inside the Sun, which reverberates around and makes the Sun sing. And by listening to those tones, we can learn about the structure of the Sun inside.
Below its churning surface, there's a nuclear furnace that will burn for billions of years. From its nuclear heart, trillions and trillions of tiny particles of radiation, photons, make their arduous journey from the core to the surface. The photons collide with super-dense gas. They take so many hits that a trip that should take just a few seconds takes millions of years. But after the photons escape from the surface as light, they take only 8 1/3 minutes to travel from the Sun to the Earth. Every summer, millions of people go out of their way to worship their local star.